Alright, so we've seen what happens with translations. Now we need to add to the mix vertical dilation and reflection on the x-axis. We've got the equation y equals negative 3 times the cube root of x plus 4. Again, the first thing we need to do is take into account the look of the parent curve, the generic shape of this graph, and those points that are going to be important to us as we try to relocate it around the plane. Vertical dilation is going to require that we understand spacing. Spacing being the distance up and down that we need to move in creating the gaps between our points. So we start with just translations. This graph is going to be left 4 of where we typically expect to find our parent curve. That means that our new point of inflection, the 0, 0 point, is going to move to the point negative 4, 0. That 3 indicates that there's a stretch vertically, and the negative tells us we're going to reflect in the x-axis. Now that means that we're going to flip over. Anywhere we were supposed to go up, we will go down. Anywhere we were supposed to go down, we will go up. Taking these one at a time, we're going to map to the point 1, 1 on the parent curve, which in reality we're going to trace the blue arrows. So we go to the right one still, only now instead of going up one space, we take into account the reflection and the stretch. If it were one space times 3, now I'm going to go 3 spaces, and because of the reflection, we're going to move down. We'll locate our new point at that spot, finding our next point, the equivalent of negative 1, negative 1. I'm going to go to the left one space. Horizontal spacing didn't change. I used to go down one space. 3 times that gap is 3, and I will go up because I'm reflecting. And we'll locate another point. From this point, we draw ourselves a curve, and we identify domain and range. Again, domain and range for our cube root functions, negative infinity to infinity. It's all real numbers in both directions.